Good morning, everybody. Welcome to the first webinar of our webinar series with CLT Toolbox. I'm Adam Jones. I'm the CEO of CLT Toolbox, and I'll be the host today. And we've got Marko, our product manager, who's going to be a presenter. So this is the first of a series that we've got. We're going to start with a very basic design of a really basic mass timber building and looking at the design of members for a post and beam office building with CLT Toolbox. So right now you're on the CLT Toolbox community forum. It's the first time we've launched something like this. So we encourage everyone here to engage with each other in the forum, ask questions, and as much as we can, don't leave our mass timber enthusiasts, colleagues hanging if they put something out there. And you can also ask questions of the CLT Toolbox team about what we're doing, our product roadmap, and everything like that. And we're really keen to engage and work with you. So this webinar series, the goals of this is to keep you up to date with the CLT Toolbox platform. We are growing at a really fast pace and building software that is hopefully great tools for you to accelerate how you design buildings. And we're going to welcome new partners as they come onto the platform and actually join in what we're doing. So if you haven't met us yet, we're an interesting group, an eclectic bunch from all over the world. We span from Ethiopia, where we've got 17 structural engineers. We've got different cultures with Orthodox Christian there. We've got Marko and Philip in Serbia, who's our product management team, helping us service into Europe and the UK. And then we've got our software team led by Iksan here in Indonesia. And then we've got the founding team on the bottom right, myself, Iksan, Lulisi, and Ringo as well. So being all over the world, I think we are now the biggest team globally focusing on just building mass timber tools. So with that, we are almost at that stage where we're building unique tools to actually solve more and more unique problems for you. So the product that we work on in the background that produces the product is the infrastructure factory. And like a lot of the mass timber supply chain, you have bottlenecks, you have QA systems, you got different processes to actually solve. And what we've been working on is the different QA processes to actually build our software. And we are getting a lot of predictability in how we actually have an idea from someone like yourself who's using our software and then actually pushing it onto the platform. So the goal of what we're trying to do is make it as accessible for everybody. So if you're starting from scratch, building spreadsheets, it's like starting on the bottom of a mountain. But the good thing with software and tools, you can actually use the concept of leverage and start from a higher place. And with that, if it's easier for you to design, it drives down the cost of design and actually can improve your efficiency to help drive down the cost of the timber option. So a few of the things that we've released this year. So in the space of 4 weeks now, we've done 2 major releases. We've done updates to our beam penetration calculators, our half lap butt and spline joints. So we do have the new Eurocode built into all of our connection details. And we've also got basic beam to beam, beam to column connections, and a slab to beam connection, and now an enterprise panel for managing company projects and also add your own suppliers and grades. And just recently, so we have been building a lot of software for a while now, and the thing that we were waiting for was this Euro launch release, which meant our wall, column, beam calculator is updated with national annexes and is up to scratch basically with what you'd expect. And also with that, a new UI and a new referral program and a new PDF engine. And in the short term, it'll be a step backwards from a design of the PDF point of view, but it means in the next month or two, we can start doing customizable PDFs and things like that, which you'll see on the platform. So what we've learned so far from a lot of you, there is a software ecosystem that's already out there, and a lot of them have a lot of strengths, and they range from supplier tools, which are free and they're quite easy to use. But one of the cons is the lack of supply chain flexibility. The CLT Designer, which has been great for a long time out there. Deliverable is a very powerful and comprehensive software that a lot of you might already use. But yeah, it's filling the gaps with spreadsheets in the design. And our approach, what we're focusing on, is giving you a lot of that ecosystem flexibility when it comes to connections and member design as well. And when you actually combine the both, and if you got an ETA from a screw supplier connecting dynamically with the grades of the member design supply chain, it adds a lot of that value in saving time and finding efficiencies. Another thing is transparency. So we've heard that a lot of engineers prefer software that's not a black box. That's why we have a lot of drop downs, education and context on what is actually going on in the app. And it's better for you, but it's also better for us, because if there's anything that's not happening right, it stands out really easily for everyone. And efficiencies, as I said, finding efficiencies can save costs on the timber option, meaning it's got a better fighting chance. And continuous improvement. So you've seen we've done 2 major releases in 5 weeks. You're going to see at least a release a month between now and the end of the year. And at the end of this presentation, I'm going to go through what our near-term roadmap is. So firstly, before I move on to Marko, a big thank you to our partners. We wouldn't be around if it wasn't for the partners of the supply chain. There is a free version of the platform, and it is a very advanced free version that's out there, meaning you'll be able to design a lot of free things if you log in, and that's thanks to the supply chain partners that we've got. And over the webinar series, you'll also get to hear from them who might support us in some of the presentations. So with that said, now I'm going to pass over to Marko, who can take over the presentation. Then you can hear from me at the end. It is worth mentioning there's a Q&A button that you can answer. You can pop your questions through, and at the very end, we'll take it from there. So thank you, Marko.
Thanks, Adam. So I'm going to share my screen right now. First, hi everyone. Thanks for coming, and welcome to the first episode of the CLT Toolbox webinar series. I'm Marko, product manager here at CLT Toolbox, and I'll be your host today for the technical side of the webinar. So I'll take you through the design of members for post and beam office buildings with our platform. So at the beginning, let's get familiar with the geometry of the building. We're gonna take you through. So we are looking at 8x6 meter grid of beams and columns with a total length of 24 meters by 48 meters. We have a story height of 4 meters and total height of 20 meters. Our structure consists of CLT floors, GLT or glulam beams and columns. And for horizontal stability, we have vertical bracings in both X and Y directions. And they're also made from glulam. Building is located in Amsterdam, Netherlands. So we're going to use a local national determined parameters and take it into consideration into the design. Going further, we'll start with a load analysis. So for the floor build-up, we have CLT floors, acoustical underlayment, and concrete topping. For floors, we also have additional dead load of 1 kilonewton per square meter. For live loads, we have Class B office areas and 3 kilonewton per square meter. Snow load is acting on 0.7 kilonewtons per square meter, and we have a wind load with basic wind speed of 27 meters per second. According to Eurocode calculations, we also have determined wind forces and wind pressure for each surface area for both X and Y directions. In this episode, we'll use some of these values for calculating the edge columns, and also we'll use this in the next episodes for calculating diaphragms, horizontal stability, and connections. Let's start with the floor design. So we'll check 5 layers, 180 millimeter CLT made from KLH. We will also use Eurocode 5 plus Netherlands National Annex. And we'll spend a few minutes on consideration of vibration analysis, to see how different analysis impacts our design and what are the options in our tool. So let's jump back to the app. And firstly, we'd like to mention that we have recently a big UI update together with our European release. So now you can even more easily access all of the calculation, especially for the member design. So we can start with a new project, or we can also go with the existing one. We'll take you through that in the next calculations. For this, we can set a scope. So for enterprise users, you can switch between the personal one or the company level. So I'll also add this to the company, so the teammates can check this as well. I'll go with CLT Toolbox webinar. So like this, and I'll type in CLT floor, and I'll take slab 101, and I'll go to the calculation. So in seconds, we'll be redirected to the main calculator, and we can start with design. So at the beginning, we can either go with manual layup, or we can select one of the available suppliers we have here. So we can go with CLH as described, with a note that manual layups are only available for pro users. So we can select CLH, and we can go with 180 as we listed at the beginning. For the design, we have default Eurocode 5, but we'll select required national annex, and we're going to pick up the Netherlands as we have in our project. Continuing with the loads, we have option for adding and selecting different load types here. So because we're calculating the typical floor slab, we only have dead and live in this case. We have default load combination, a loading code, a consequence request. So we'll go with the medium one, as this is something that is related to reliability of the buildings. Now, UDL will also remain here for imposed load to category. As we mentioned, we'll keep up with the category B for office areas. The design equations are here for modification according to national annex. In this case, a default and only available is using both one. Service class, we can keep to 1. Self-weight will be considered. We'll add topping as we have in this case, and I'll just add 1.25 as we have 50 millimeter screed. Additional loads will set to 1, and we'll have 3 kilonewtons for lie load. Going further, we have the analysis data. So firstly, we will select the condition type. So in this case, we have already a 2-span equal. I just typed in 6 meters, and we'll configure the other inputs here as well. So we have option for considering the cluster error or stiffness in other direction. This is mainly considering the supplier production technology and the edge glow lamellas. So in this case, we'll keep to no, but just to know that beside every input, you have this green button where you can find out more information about each specific inputs and educational content. The same applies for the analytical method. So how stiffness is being calculated. We have different methods incorporated within the app. So you can switch between extended gamma, or shell energy. But again, for guidance and how you can continue with this, or also where you can find more information, you can find in the educational dropdown, as well as information how the calculation is performed in the background and limitation for the selected method. So we can continue with extended gamma. Going further, we have option for the design code, the deflection data. So we'll keep this as default, and we'll come to vibration part. So as we mentioned, this is something that can be very important in especially in the early stages of design, is especially because the CLT and vibration are not included in the current Eurocode. So we implemented different methods where you can take in some of these for addressing your specific situation. So we can start with HAM method. This is a method developed at Technical University of Munich, and based on it, the Austrian National Annex included verification for CLT vibration. So we can type in 8 meters for the secondary width. Damping will remain 0.03 as recommended with floors with screed. We'll keep the floor with higher demand, and we'll add a screed stiffness consideration because we want to add the in-plane stiffness in this case. We'll have 50 millimeters, and we'll just slightly increase the stiffness of the screed. So based on it, we can see immediately that this verification is not satisfied. And also, we also have to note that with each of these methods, we have some limitation. So in this case, a HAM method is only applicable for the stiff support. So in case we have supported with GLT beams, we know immediately that the results will not be that precise. So we can switch to revised Eurocode. Know that FP innovation is also applicable, but it's more likely that this will be useful for the US region. So if we go to the revised Eurocode, we can see that some inputs are new here, especially with introduction of floor performance levels. So again, educational content can be very helpful here. There is introduction where you can start with what performance level is suitable for your starting point and your specific construction you're taking. So we can go with second performance level. We'll keep the secondary width as it is. Walking frequency, we can start with 1.5 hertz. The floating screed, again, will have the same values as we have on the previous method, and we'll just here in the additional input where we have support condition, we can change from rigid to flexible, so we can add the contribution of the beams and have more precise values considering our situation. What we also have with these inputs, we have properties of the beam, so section, depth, width, module elasticity and self weight. We'll keep these values for now, as we don't know what are the exact dimensions of beam. We'll calculate it later, so we can come back later and check the results again. So for the output summary, we can see that in this case we have passed deflection, vibration, ambient shear, and bending, and we can go into details with these tabs on the right. So if we want to check some intermediate results, you want to check references, or even cross-check with other software, you can trace down the calculations from the start to the end. So you have information also about the annexes, loading code, both for ultimate and serviceability limit state load, analysis part. So for each combination, you can see what are the shear forces and bending moments, deflection, vibration. So in detail, in this case, you can check what are the all the criteria and the necessary requirements. So for the frequencies, velocity, and acceleration as well. And the last part will cover design code. So a string check for bending design, shear design, and rolling shear. And you can see also the checks for governing load combination, as well as utilization number. We'll save this, and we'll go with our design. So as we check the CLT floor, we'll also go back into presentation and go with the beam. So for calculating the beam, we'll take the tributary area of the middle beam we have. So we have the 6 meter, we calculated the dead and imposed load, and we have 18 kilonewton per square meter. We're going to use that load in information into our design. So I'll go back into calculator. I'll just firstly save what we have for the floor, and I'll go back on the project level. So in project level, you also have basics of project management here. So you can also, when you calculate something, you can assign to colleagues. You can invite other users, start some discussion about some issues you encounter. And also you can add calculator or even calculator groups, so you can sort it by levels. In this case, we'll just add a timber beam. We'll name it GLT beam B101, and we'll create this calculator. So we'll at the start, we'll select firstly the material type, the grades, and the section. So you can switch between GLT, LVL, and solid timber. So you have option even for checking different materials. And now also with a specific supplier, or if you onboarded them manually with the enterprise customer, that's something that will pop up here. For the grades, we can start with GL248C. We can start the design by 320 by 620. And we can see if this is something that we can proceed with. We have immediate information about the section view, and we can continue with design. So for the design methodologies, I'll quickly select the same inputs as we have on the CLT floor. For the loading case, I'll keep most of the things as it was on the previous design. I'll just, the self weight is already considered, and I type in 18 and 18 kilonewton per meter. And we'll go to analysis part. We have simply supported, we have 8 meter span, and we also have introduced an option for the shear deformation. So from the previous release, we now have an option for even more precise consideration of the shear deformation. And if for some reason you don't want that to be included, you can select it through this menu. We'll keep it as it is for now. Deflection data is something that we'll also keep as it is. And the last part is concerning some of the coefficients for Eurocode, and also a requirement for the K-crit. So in this case, we'll select no, and we'll take it as 1, because we have the beam is laterally supported with the CLT panel above continuously. We can see that in this case, our section is not appropriate, so we'll increase it more. So we can start with 680 to see if this is something that pass. No. So we'll increase even more. So we can start with 360, and we'll increase even more the height. So hopefully this is something that is right. Yeah. So it's practically maximum utilization for the deflection, and we can quickly go through the properties if we want to see some of the information here. Annexes, this should be same as we have on the floors. Loading code, so you can see all the governing load combination, analysis, deflection, design data. So we'll not spend too much time on the results here because we have other calculations we're going to take through. We're going to click Save and jump back to our next member design. So as we design GLT beam, we're going to have internal GLT column as the next part of the design. We'll also use the tributary area as marked on the imagery on the left. So we have area of 48 square meters. We have, based on it, we calculated the loads from above, and we also have beam reactions from the hang beam on the sides. So we'll use this information as inputs and go with the calculation of GLT column. So I'll go back on the project level, and I'll add a GLT or timber column calculation. I'll call it GLT column C101, and I'll create this calculation here. So same thing as we have for the GLT column. So GLT beam will select the material. We'll go with manual input. In this case, I'll select GL24H. I'll start with 320 and by 320 in this case. See how that goes. For the analysis part, I'll type in what is the height of the column. So I'll go with 4 meters. For both lateral restraints, I'll select no because we don't have any of restraint for this column. I'll select Eurocode calculations, and I'll go with the loading data. So in this case, we have both loads from wind and snow from the roof as it's transferred to all the way to the ground floor columns. We'll keep the default load combination, and post load category snow load will keep as it is, and we'll keep the self weight considered, and we'll just type in the appropriate amounts for all the loads. So I'll quickly just see what we have. So 624. I'll try to be quick on this. We have 576, 32.6, and for snow, well, we have, this is 55.6, and this is, so we have 0 eccentricity because we have a load that is transferring from the same axis from above. For the connecting beams loading, we'll only select, or keep selected the top and bottom, and we'll also type in what are the reactions forces from the hanging beams as well. So we have 76 and 72. So let's do that quick. And we have 0 for both wind and snow. For the eccentricity, we'll keep the half of the column. So in this case, it's 160. And that will automatically be applied, so you can see where is the acting force of reaction from the beam. So the same will be applied to this case. So 72, 0, 0, and I'll type in 160 as well. So when we type in loads, we can go to the next. So we have also option for a lateral load. Since this is a central column, we don't have any applied wind to it, and we can go to the next. Also, for the design code specifics, we have cases, again, a K-crit calculation. So in this case, we'll type in no and keep with 1 because we don't have any lateral force applied. We can see that in this case, our section is not satisfied, so we'll increase this as well. So we can go 360, 360, see how this go. Not good, and we'll try to go with 400 by 400. So this should be appropriate for the design. It is, and we have all the information in details in the tabs on the right. We can go in detail if we want to check some of the calculations specific, but in this case, we'll keep to we'll just save and try to calculate the other or external column as well. So let's just click save and go to the next calculations. Okay, so let's go back And in the meantime, I'll switch the tab for presentation. So we have external column design as well. So in this case, we'll pick up one of the columns from Facade. We have a tributary area that is applied to this situation. We also have all the loads that is specified for this case, as well as the same beam erection. So because we have only modification to the previous design, we're gonna use the previous column. We'll just copy or duplicate the this case we've been using, and we'll just rename it appropriately for the design we're using. So we'll go C102, and we'll create the calculation easily and just modify what are the differences compared to the previous design. So at the beginning, we'll just start with inputting what are the differences in this case. So we have, again, for Euro region, we have a required national annex. So I'll just quickly select Netherlands. We have, for loading code, we have the same loads. We'll just have the different amount according to the tributary area. So I'll quickly see what are the differences here. So we have practically half of the loads that is applied on the previous. So we have 372, 288. So let's do this fast. We have 27.6. And we have 16.6 in this case. Eccentricity is the same on 0, and the values of reaction is the same, but we'll just have one beam. We'll just modify the eccentricity accordingly and type in zeros for the wind and snow. So in this case, we have appropriate design, but the only difference is in this case, we have the lateral load from wind. We'll have in direction 8 by 86 kilonewton per meter. And we will type in this case, to create to be calculated with a compression edge. So when we select all the information here, we can go with results. We can see that for this case, it's appropriate dimension. We can even have utilization better, so we can reduce the cross section for a bit, and for external columns have a bit narrow one. Results containing all the information are listed here, so it's the same as in the previous calculation. We have information about the loads, annexes, analysis part. So even if we go scroll down here, you can even see what is happening with the appropriate load combination, including axial force and moments in both directions. So that being said, we can save this as well and continue with our example. So what is next is we have beam penetration design. So we're going to take you through one of our specific calculators with the ability for checking the penetrations in the GLT beams. What is interesting is this can, in a lot of cases, cause a lot of problems, especially in the later stage of the design. But you can also use this and try to check what is happening, and if some of the members what you're using can be used with the same depth and width, but just using some of the reinforcement that is also possible to use in this case. So we have the tributary area, we have calculated the loads, we were taking the governing load case from the beam design and factorialized load on the beam, since that's required in this calculator. And we also have information about the penetration locations and the type of penetration that is acting on the beam. So we'll jump back to the app. We'll go to our project level. We'll add a calculator and select beam penetration. So I'll just type in and go with this. So concerning the beam penetration part, we're going to take the same properties as we have on the previous beam calculation. So we'll select the manual input, we'll select the appropriate grade. So in this case, we have 24C. For depth and width, we'll take through 320 times 720 as we have designed. As soon as we enter width and that will be applied on the dynamic imagery. For span, we'll take 8 meters as we have used it for the number of penetration. So this is the most important part in this case. So we'll select 3 because we have that as a requirement. For each penetration, we now have options of selecting the type, the location, and if reinforcement is used or not. So we're going to select the rectangle for first and third one. For the second, we'll select the circular one. Also, we're going to quickly take back to the presentation and see what are the locations. So we have 100 times 250 millimeters at 1.8 and 6.2. So the first and third one is on that location. So we had 100 times 250 at location is 1.8. I think we'll have this on the middle of the section, so it's 360, and we're going to firstly check all the penetrations without the reinforcement to see if it's possible to go with that. I'm going to same input to have on the on the third penetration, so just double check 1.8 and 6.2. So it's 6.2. We'll have also unreinforced in this case. And for the third one, or in the locationally, it's the second penetration. We have the circular one. We have diameter of 80 millimeters. It's on 3 meters. We're going to keep it a bit higher, and we have the unreinforced as well. So we set up the geometry. It automatically will be shown at the dynamic imagery, and we'll go back and see what are the applied loads. So we have 48.6 kilometer total factorized line load, and we're going to put that into the design methodology. So as I mentioned, it's 48.6. So, and we're going to keep the gamma as it is. At the moment, from user, it's required to input the total factorized load. As we implemented the national annex and load combination, this is also something that will pop up as an option in the future updates. For the design methods, it's worth mentioning that this is according to latest draft Eurocode 5, because we, as I mentioned, start implementing the new Eurocode provision, especially where there are clear gaps in the current Eurocode. For the design data, so we have now options and parameters for inputting, especially for this design. So we will keep the service class 1. We have some of the inputs, especially considering some specifics to the new Eurocode. So you have the educational content, and you can find whether you need to change something, or you can go with the suggested coefficients. For the load duration, we're going to just select the long term and see is this something that we can continue with. So we can see that the tangent is not passing without reinforcement. So we have either option for increasing the section or selecting the reinforcement. Considering that its best situation is to not change the section, we'll select and see what does the reinforcement can help in this case. So we're going to select for the first and third one to change the reinforcement. As soon as we change this, we have the additional input for the screw data, and we're going to select, we have ability for selection of our partners here. So starting with Eurotech, Rotoblas, Siga, Spax, and Simpson Strong Tie products, and with each product, when you select, for instance, if we go with the Eurotech, you have a full the supply chain availability here. And even if you're not familiar with some of the products over here, you can select the educational content and see all the information about the types of screws, screws family, thread type, head type, diameter, length, service classes, and specification, as some of these things are different from supplier to supplier. In this case, we can go with the fully threaded cylindrical head screw, and we can type in some of the diameters here available. So I'll select Constru X 10 times 600, and we can see if this is something that is okay. So also with the output summary, below that you have the table with information about exactly in which penetration you have a failure and what is the utilization number. So we can see with the reinforcement that for first and third one we have the utilization that is okay, but with the second one we still have a tangent verification for the unreinforced penetration that is failing. So we can either narrow down the diameter, we can try to see with the other parties in the project to maybe move it a bit, or we can try with the reinforcement. So let's try in this case also with the reinforcement, and go with this. So we can see that in case of using reinforcement, it can be a big difference for some location of penetration, and even something is in first insight is not possible. We can use it with just appropriate design method and also reinforcement type. So also what is worth noting for in this last part of input, we can change and modify reinforcement data. So you have option for even increasing the number of screw if you have really high forces for on the location of the penetration. You can also modify the positioning of the reinforcement. So you can see that on the section view here. And in these tabs on the right, you can also check in details about all the intermediate steps of the design, and if you want to go into detail and check what is failing and what you can do to improve your design. So also considering the action, so you have information about the action forces, bending moments on the location of each penetration. You have the geometric limitations, so according to the geometry and the position of the penetration we use. Verification for the flexure, shear, reinforcement geometry, and the reinforcement design at the end. So that being said, we know that we can keep up the section we have, and we're going to click Save and go further. So we are now at the end of what are the design examples and calculations we prepare for this session. We'll take you through some specific features you can use in case you're using a supplier that we are not partnership with. We don't have the partnership yet. So we recently introduced our enterprise features, and with these features you can manually configure some of the supplier properties and use them on the company level. So I'm going to spend a few minutes showing that as well. So if we jump back to our project level and get back to CLT Floor Design, we'll notice that we have additional supplier that I manually configure for our organization. So this can be done on any company level. So I added new CLT supplier, and within this I have onboarded one panel. So this can be used for it's not visible just for me, but it's for all my teammates and parts of our on the company level. For the enterprise customers, that can be configured on the enterprise part, suppliers, CLT suppliers, and also you have ability not just changing the layups, but also adding new grades for CLT, GLT, and with GLT you can configure in LVL and solid timber. So I'm going to quickly show you how this can be done. So I've added a new CLT supplier over here. You can edit supplier in terms of naming available regions and even define predefined available grades. And you can here on the layups, you can configure already defined layups with modifying them, or even adding new one through the system over here. So if you want to modify or create a new one, this is how it looks, the system on the back. Once you do this, it will be available through all the people in the same enterprise company part. So that's quickly on that, and it will be available in all the calculation, not just the member, but also on the connection part where CLT is included. Second thing I would like to point out is I would like to show you a preview of our new fire options. So we developed a new fire module that is available on alpha. So we're doing heavy testing at the moment, preparing this for the release, for the next release. So what have been done as a major change is we practically reduced redundancy with the multiple calculators that we have previously on separate for the fire and ambient, and we have one ability for adding fire in every project. So I'll just go with to show you quickly on the CLT floor calculator. So when we enter a floor calculation that we made, we have option for checking fire easily with just add calculator function, and when we click fire, the calculator itself will take all the necessary inputs from the design you perform. So we'll take the material, the section, the loads, national annex parameters, and you'll only configure the fire part in this case. So you have option for selecting what's the fire resistant time, what is charring rates are using for glue line integrity, so are certified glues are used or not. We also work on the educational parts. We have information about the specific for each supplier. What are the exposure? Is it underside, top side, both sides? Some specifics according to the latest draft Eurocode 5. So we again start implementing some of the latest standard because that's where the fire and CLT is mostly developed. Biggest flexibility here is in adding multiple layers. So you can select and verify the whole build-up here. So not just the CLT or just with one protection, but practically you can add as many protection layers you want. And for each layer, you can select what type of protection layer you're using. So is it the plastic board, gypsum board, LVL, solid wood, and so. And for each protection layer, you can select, is it the calculation method with the Eurocode or with the specified information from the targeted producer you're using. Concerning the result, as I mentioned, everything will be copied from the design you've been taking previously. And concerning the result, you have information about what is happening in case of fire, what is the reduced cross-section, so how many layers you have after the design, and also verification according to fire. So it will be including loading, strength, and all the necessary inputs. So, and that was quickly from the information that we would like to show in this case. Hope this was useful for all of you who are especially who are first time encountering with our platform and our tool. We're happy to, if you have any questions, to discuss this in the next period, and looking forward to see you on the next webinars as well. Thank you.
Sorry, Marko, my audio, I was zoomed in on a part of the screen, so I was frantically trying to find the unmute button. Great work, Marko. And thank you, everyone, for your questions. So we'll try and get through as many as we can. We've already got some really good questions. So we'll start with. We'll start with this one here. So Marko, national annex for Belgium.
At the moment, we have 9 national annexes, not including Belgium at the moment, but we have developed the infrastructure that we can add national determined parameters easily. So we'll targeting to include all the European national annexes at some point. In the meantime, you can use manually configuring the national annex. So you can, for each calculation, you can configure all the coefficients and go with the design with that. And in the meantime, we'll work to include the Belgium, so it can be selected through the menu as for the other national annexes as well.
Yep. Great. And then we've got a this of course comes up a lot and we can talk to, but for the span of beam or floor, will there be more possibility cantilevers 3 or more unequal spans?
Yeah, so at the moment we have a limitation of the support type. You can switch between the simple double support and 3-span, but what we are already developed in our engineering side, the update for the analysis, so it will be including all possibilities with the cantilevers and point loads, and that's something our software team is currently addressing. So we hope that will be available through the app already next month.
Yeah, and just to give everyone a taste, I actually see Wenderad on this webinar, so this is some of his magic. So you can see here, this will be just incorporated to all of our calculators, so you could easily do the span lengths, things like that, free support, and you'll be able to add point loads on top, as well as, so point load loading as well as your UDL. So it means you can get your unbalanced loads and everything like that. So that's pretty deep in the process, and we are aware that's probably the biggest gap in our software right now, alongside incorporating, finally pushing that fire scenario to the app as well. So thanks for that question. All right, another question we've got here. So we've got student university version of the software. So I might answer that one, Marko, if you don't mind.
Yep.
So yeah, we haven't publicly announced this yet, but in general, we are, rather than give a student version, we are keen to give full access to the full software, and that's including the enterprise panel to universities. So what we'd do is connect with a professor or something like that, and then they can add their own users with an enterprise account. So what we're trying to do is help grow the pie and contribute to the industry, and helping the education sector is one way. So if you can get through us on the website, or Corey, maybe you can put your contact details in chat, send her an email. And that goes for anyone on this call. If you want to connect your old university onto the platform, we're happy to help like that. All right. So Kevin here asks, are there checks in the fire situation with remaining section in the beam column CLT? So maybe, Marko, you can elaborate a bit more broadly on the other calculators as well.
Yeah, that's of course, that's a great question. As we mentioned, we're having the fire module developing at the moment, so it's on the alpha for the CLT. The similar abilities and knowledge would be for beams and columns. It will be added as the add calculator function, and ability for checking what is happening in case of fire. So at the moment, it's only for the ambient, but we are planning for including all the fire checks for all members in the next release.
Yep, great. We've got a question for penetration calculations more than 5 penetrations. We had 1 for a while. We're excited to get 5, but Marko, what about more?
Yeah, so we had to define the scope for the first version we have. So at the moment, we were limited to 5 penetration. We'll also, as our system is to constantly update all the calculators and improve them. That's great feedback, because now we know that's something that is requested for and needed for the user. So we'll add it in the next update for this calculator to allow even more penetration. So thanks for that.
Thank you. And Stefano, so I've got, if I wanted to, sorry, I'll remove this one now. So for Stefano's, if I wanted to consider the vibration of a timber beam, for example, floor of wooden joist, is there the possibility of carrying out this verification?
Yeah, so at the moment for the floor verification and vibration, it's only made for the CLT. In our pipeline and future development, we're also will include other types of floor structures. So when we add typical wooden joists, we'll be able to perform vibration analysis. In this case, in the simple beam calculation, it's not included.
Thank you, Marko. And so from an anonymous here, we've got, regarding subscription, is a possibility to trial the Pro for a few weeks? Would it be possible to pay via invoice and not directly by credit card? Absolutely. We're a startup. Any way you want to pay money, we're open to. And this would not be possible regarding our accounting. So that is a normal thing, and it is normal for us to go through some sort of procurement process with companies. So we do expect that, and we've done it a lot. So we can work with any way you need to go. And yeah, just reach out and we can give you pro access. Usually we'll just catch up, have a demo, and then, 3 weeks later, a 3-week trial or something like that, and then just hear what feedback you've got and take it from there. So thanks for that question. So yeah, just a reminder, you can see Corey's details in the questions there. So, but yeah, great questions, everyone. So I've got a few slides to end on, and thank you, Marko, for kicking off on the first webinar. All right, so I think you can see my screen here. So what to look forward to? Marko mentioned a few of the things. So we've got, the way we split our team up is in 3 separate teams. On one team, we've got major updates to our 6 DAO connections, and one of them is going to be moment connections as well. That's been in high demand. You can see the steel to CLT connection details will start to be rolled out, and that'll be also built with the ETAs of our screw supplier partners as well, built into those connection details, which is exciting. On the members team, we've got the new analysis, which we mentioned. Again, we mentioned floor penetrations as well. So if you've used the ProHoltz guide, you can see they've got the grillage method. So we're gonna have a dynamic way to easily change the location of your CLT penetration, and with that, actually have a simple, quick way of designing with that. Next to that, TCCs, rib decks, and studs. And then on the features team, export 2.0. So at the moment, with PDFs, it does export larger PDFs, and we've had the feedback that we need to simplify that and have 1-page PDF reporting as well. So alongside that, being more interoperable with the ecosystem. So bulk export and import with CSV files. And if you're using Global or eTabs, or something like that, being interoperable there. And adjacent to that is also our APIs as well. So we've started working on that, and that is also in big demand. So we'll have something ready, we're hoping by July, but again, feel free to be in touch if you want to be part of it. So there's some of the things to look forward to, and that's real near term from our perspective of what's happening. So for the next steps, so each month we're going to be doing a webinar. The next month is going to be lateral stability and connection detail design. It's going to be on the same time. In the meantime, sign into the app, check out the free version. Pretty much all of today, except for the beam penetration, was on the free version. We are doing a lot of demos right now with company presentations. So if you want to show your colleagues, we can do a lunch and learn / CPD presentation for you. So with that said, thank you so much for joining. This was the first time we've done a webinar on this platform. So really appreciate your time today, and we hope to see you at the next webinar, and send us an email anytime if you want to get in touch with us.